Welcome to Toronto Machine Learning Society Annual Conference. My name is Aarti Malhotra, and I'm glad to be the moderator for this session. I'm honored to introduce Ms. Olga today. Ms. Olga currently is a Senior Manager, Advanced Analytics at RBC, where she applies machine learning and automation for capacity planning and optimization. She has been working in the field of data science for over 10 years. She brings data to life through machine learning, analytics, and visualization. Outside of her work at RBC, she has worked directly with global organizations as well as prominent Canadian nonprofits on various data science and analytic challenges. May I now request Ms. Olga to enlighten us about AI augmentation in finance. If anyone has any question, please feel free to post in the chat. We will have a Q&A session after the talk. Over to you, Ms. Olga.
Wonderful. Thank you so much for the introduction. It's a pleasure to be here, and I'm really great we can begin. Sorry for a bit of delay. I will start by introducing the agenda for today. So in this session, we are going to cover AI augmentation and how to design AI augmentation to support decision makers. We will walk through several examples of AI augmentation and discuss some of the key components of defining the interaction between machine learning and humans, and some of the pitfalls on how to deliver ML output to decision makers, as well as how to build trust in AI augmentation. So I hope you will stick around for this session, and here are the 3 reasons why I think you should. First, this topic isn't covered a lot. So you would see in the literature a lot of mention of natural language processing, image recognition, robotics, and other topics. But AI augmentation is one of the main applications of machine learning that is currently being worked on and delivered. In addition to that, it's a people-centered area of machine learning where the work is focused not on replacing people with models and the processes and tasks that people do, but rather making humans better and what they do today and helping them to do their work in even better ways. And some of the people out there believe that this is really where the future of AI will be, helping the human to be better in their processes and their decision-making, their learning, instead of replacing the person, replacing the human. So this is a practical skill that you might consider for the future and the good investment that you are doing today by joining this session. So as I mentioned, decision augmentation or AI augmentation, and I'll cover the definitions in a minute, is one of the key areas of application of machine learning and AI today. According to Gartner survey, where they look to leaders of businesses and the industry to understand where the budget for AI and machine learning are actually spent as opposed to future plans. So they found that decision augmentation represents approximately 21.6% of the overall budget of AI for industry today. So although it might seem to many people, and I hear that a lot, that AI augmentation is a bit of a niche topic, something that isn't covered a lot in the journals and in the literature, it's an important topic to cover and to learn more about. So since there are a lot of different people attending conference and all of you have different backgrounds and are at a different journey in your career. I thought we should cover the definitions a bit, and I also provided some of the synonyms that essentially are equivalent or replaceable with AI augmentation. So the first definition of AI augmentation really covers the core of what it is. It is enhancing the human intelligence rather than operating independently or automating some of the tasks that people do. And the second definition here, what I particularly like about that one, is the cognitive performance. So enhancing cognitive performance of humans and including learning, decision-making, and new experiences. So the cognitive part is key here. As humans, we have our limitations. Some of our limitations are physical, some are mental. So for example, attention span, there is a limit to it. So when humans solve problems that require prolonged hours of concentrated work just to grasp the problem, it might cause it not to be solved and postponed. We are all great at procrastination. And in addition to that, there are biases. So when humans, there are various biases out there. One of them is confirmation bias. When humans see information that they haven't encountered before, they tend to disregard it and not believe it. So so AI is better in some of those gaps or disadvantages that we have as humans, and so it could help us and enhance our ability to make the right decisions. So just to align, you've seen decision augmentation, which is an area of AI augmentation that helps humans make better decisions. It's also known as augmented intelligence or intelligence augmentation. So all of those things mean the same concept. So now that we all are on the same page of what AI augmentation is, let's look at an example of one of the earliest applications of AI augmentation, and that is CAT mammogram. So CAT stands for computer-aided detection, and that really tells you how long this technology has been around. We don't usually call things computer-aided anymore. That is a term that comes from 80s and 90s. So that's that was a time when they started using AI augmentation to help radiologists improve the accuracy of the diagnosis of breast cancer, as an example, and reduce the misdiagnosis there. So prior to this technique being applied, it would take a long time for radiologists to analyze the image and make a decision on the dense growths out there that are highlighted on the image A with a red circle. So there were long wait lines for this kind of analysis, and only very highly skilled and specialized radiologists could do that. When they've introduced the early AI augmentation to it, the goal and the hope was to improve patient outcomes and reduce the wait lines. So you might think, what an exciting time, early 80s, introducing this technology, applying machine learning and AI to areas like that to save life. Well, maybe and maybe not. When the Department of Radiology and University of Chicago, when they came up with this in the late 80s, they actually were not, the application were not welcomed. A lot of radiologists felt threatened. by the fact that one day their job could be totally automated and they wouldn't be needed anymore. And also they felt it was quite time consuming for them to review every potential growth out there in a tissue that could be cancerous. So they had to go through reviewing every area that is highlighted, and they didn't like that. It actually took them more time, not less. So that is the reality of AI augmentation. As we have, you are observing probably some of that today in the headlines, the assisted driving out there. There are a lot of negative headlines that where people don't trust in assisted driving and question it. Or another example could be the early disaster recovery. Oh, sorry, the early disaster alarm systems. So there is always a lot of backlash when a false positive happens and a lot of people receive an evacuation order or an alert on their phone. So some of those, this is an area where AI augmentation is both exciting and also challenging. And I think a lot of interesting applications of AI augmentation are yet to come. So let's look at the process of designing AI augmentation and what are some of the key components. What could help you to come up with how do you come up with a use case of AI augmentation? What could you do today in your work in the area that you are focused on to start thinking about your use case for AI augmentation and how you would get there? So one of the things that is very important when starting to think about it, the goal is not to start with the data or with the machine learning algorithm selection. The process starts with the focusing on the interaction between the human and the machine, and where would that interaction happen, and how to balance and have the two collaborate. So that's really where it starts, where we define what could be done by machine learning and what should be done by the people. So that's the first step when we collect the evidence. So the process here is to understand the problem. What is it that humans do today to come up with a decision to do their learning? What are some of the areas that AI could improve in that process? So for example, the blind spots that they may have, or biases that they may have, where could AI come in and make the process better? And what data do they use today? What are some of the key inputs into the decision-making process that they really value? So going back to our example of diagnosing breast cancer, how can we make breast cancer better is a big question that could be addressed in so many different ways. There are so many different data points. You could look at genetic history, body temperature, blood work, patient symptoms, and how they express them, and so on and so forth. One of the reasons that the scans and the work of radiologists is so important, and that's where the AI was introduced, is because it's the last step of the process in the diagnosis. And it's also one of the key inputs into the decision of the diagnosis. So that's a good area to introduce machine learning to. That's a good area to focus on. The next step is to simulate the actual process. What is it that humans do today? How do they drill through the information? How do they analyze the overall impact? What do they think of as a big picture view of the data? The framing of the question is very important part. So solving the problem and how they think about it is very important. If you miss some of the information that they're used to taking in, and AI doesn't take it into the consideration, it could be considered incomplete. So they would continue going to other places to search for that information. And so the AI product that you might be building wouldn't be useful to them. And finally, presenting the results to the users. This is an extremely complex process. And this is really where it moves from machine learning to AI. There might be multiple models that are involved in designing the AI, but this is the place where they all come together in a way that is clear, concise, and easy to grasp for the human. So a typical machine learning output would be a score, a number, or let's say, for example, a recommendation model may present a list of top 5 products that user might be interested in. For the AI augmentation output, it's typically an entire interface with various inputs that were gathered from different places and presented to the user and help the user do their job. And the final step, complete the mission, is actually done by the human. So they should have everything they need to make a judgment and potentially discuss that with others. So there might be ways to collaborate for multiple humans to interact with AI augmentation. When we think of decision maker, we usually picture it as one person, but in reality, decisions in large enterprises and in sophisticated processes are decisions that are made by multiple people. And they all provide their input into it. And only then someone makes the final decision. And finally, they have to make it happen. They have to take an action. And this could be also something that the AI supports. So in the example of the CAT scan, they had an interface, and they still do today, where the radiologist checks and selects the potential cancerous areas for surgeries. So that's the high-level process of what is involved. And now let's look at a particular example. So let's take an example of a mobile app that helps customers manage their finances. So the team that owns this app are our users. They would be the users of AI. And they would like to understand the usage patterns and make decisions on the management of this app. So the question that they might have would not necessarily be a question that is can be simply defined by the data. We are looking to see if there's a number of users of our product, if it's normal or not. So this is an example question that they might be looking for insights. So the way that we have it solved today is month-over-month reports, or maybe even real-time reports that present the usage of the app. The important thing to point out that they're still looking for more information. They have those reports already, but they don't satisfy what they're looking for. So they aren't there for the data. They want the insight. And in order to get that insight today, they have to do a lot of work themselves. They have to go and analyze, meet, and make decisions about it. So this is the use case, and let's try to solve it using AI augmentation and going through that process. So one of the first things that they've asked there is normal or not. So consider what might be some of the things that they think of as normal. Would it be a particular number? Typically, it would not. So they might be thinking about having an idea of what the actual traffic, what the normal traffic would look like to them, but they would know that 7 a.m. is different from 8 a.m. traffic, and traffic on Black Friday is different from a typical sleepy Saturday morning. So the normal isn't a number. They want to see engagement, and they want to see the users as what it should be. So we need to define the normal for them, and we need to with them, and we need to then from that define what the not normal would look like. So the collect the evidence step starts by framing the scenario. So what is normal, what is not? And one thing that I learned when going through the various decision-making analysis is that the problems don't exist out there. So what is not normal is not really clearly defined. You need to define that, and we need to all agree on what is a problem and when does it become a problem. So really, problems don't lie on shelves. We actively define them and we agree on them. So the AI augmentation that we are designing here is to help them detect those problems, those days when they're not having a good usage, not having good engagement from their users, and alert them, let them know what is happening. The process usually starts with looking at how do they define the users. So it could be active users, but presenting just that metric would be not enough. It would be an oversimplification, because they need to understand the entire problem in order to really make a decision. So you would need to gather other data and present it together with the user data they're actually asking for, without any oversimplification. So it has to be a full framework. For a lot of companies, where it really starts is by searching the data. So in an ideal world, we would start by building the AI product. But the reality of many companies today is that the app may not have proper events and tracking in order to start working on the problem of in order to start working on problem users and identifying those problem users. There might be data issues where data is stored in different systems and siloed across the organization, or not a clear definition of the metrics that you're using. So if any of those areas aren't solved yet, that you might have to start there and start solving this problem. So hopefully the legwork is already done. So then the next step, once you have the definition of the problem and you have the data that represents the full framework in order to make decision, is to understand which part of the human analysis do we want to simulate using machine learning and AI. So Andrew Abella, when he looked at how we process information, defined 4 distinct ways how we tend to approach analyzing information, making decisions based on that. So it could be personal, it could be a habit, or it could be driven by what the data is and how it's presented to the user. Some people tend to compare, and some people tend to look for relationship. And this is where you would look again to the users to understand what is their mental process when doing the analysis of the data available and solving this problem by themselves without AI. So for our app, we say they approach it through comparisons. They compare what it used to be with they compare what it is with what they think it should be. And humans are predictive machines. So we have, through our learning and our experience, we have a memory and recall process that happens that help us identify if this is abnormal or not. but we are also human, so sometimes we forget. Sometimes we are simply new to our role and not prepared. We don't have enough information, don't have enough experience to make those decisions. So this can be solved through AI, obviously. Another thing that they are looking at is the distribution. So the distribution could look like the frequency of access to the app. So they could look at that. It could be at the number of users that are there using the app. So representing the distribution could also help them make the decision. So finally, we come to the AI augmentation solution. Once we analyzed and understood which part of the process, we can simulate using AI. So in our case, we decide that since they used to compare to what they know about the users, we will use historical time series data. And the process of selecting the model that we want to use is unique to each use case. But in this case, we decided that we want to use the Bayesian state-space time series model. And we would use that to take in historical data and compare our prediction based on that historical data, so what we actually see. So we are predicting today in order to understand if today is normal or not. So if you look at the image on the right here, you would see purple tags that are highlighting everything that happened that wasn't predicted to happen. So in other ways, we are highlighting anomalies using this model. And those anomalies are then flagged and collected in order to present to the user. The output, the final presenting the results, is the key step. And we don't necessarily want to present that timeline chart that you've seen just now to the users. It might be too scientific, difficult to interpret, or depending on the amount of data you have, it might be too much. So I recommend using pizza approach when presenting the information. So one slice of pizza might feel nice. 2 or 3 slices might be a bit too much. And you have to understand what is that perfect fit for your users and your audience. So this is an example on the right here is what the output could look like. The app performs significantly below expected on Apple devices. User segment is Apple 15.0.2 version, used the app 28.6% less than expected. So this is the output of the model combined with what we already knew about the users. So the segments might be already present in your data, or you have defined them specifically for this use case. And there is a next result, that it happened for 2 consecutive days. So we are presenting information to the users, not just it's abnormal, because that wouldn't be enough. If we just say 28.6% less than expected, that's not enough to make decision. The next question you have is how and why, what is happening. But when you highlight the segment to them, so segment could be anything. In this case, it's the particular model of the phone that might require testing. That makes it actionable and that makes it clear. And that's why the framing, the taking all the data that they need to make a decision is so key. And it really shows in this. So they would understand what they should be doing next. You could also ask them to provide feedback. So say if this was helpful or not, if they acted on it or not, and feedback into your model to help train it and improve it. So we've collected the evidence, we did the simulation of the analysis, and we've presented the results to the users. So now it's up to them to complete the mission. They might schedule a quick meeting to talk about it, or they could create a story in Jira to ask someone to test the app for this particular model of the phone. So this is what the end-to-end process in a nutshell looks like. I wanted to, before we go to Q&A, I wanted to talk a little bit about explainability. So the key part to getting your AI augmentation product be used by your users and valued is their trust. They need to trust, and in order to trust, they need to understand it. So there are many reasons why it's important to think about AI explainability, not only at the end, but also throughout the process while you are designing it, is because it could be important for the users and in order to build their trust, in order to have them continuously using the app. And not all models are equal. Some models are easier to explain than others. And also, it's not all about the models. You have to design from the beginning how and present the information on how the data was collected, what data was collected, why some of the data points were collected and included into analysis, and not just the last one. And if you design for explainability right away, then it reduces one of the key reasons why there is a sometimes lack of adoption of AI augmentation, is that fear of unknown, the fear and not understanding of how it actually works. So explainability helps with tackling this issue, which is the number one reason why it's not getting adopted. So I've already mentioned that you need to think about the what, the how, and the why was involved, not just explain exactly how the process works, but what do you use and why you use it or not. So I'll leave you with explainability, and hopefully you'll find this useful in defining your AI use case and starting working on your AI augmentation problems.
Thank you, Ms. Olga, for the great talk. We have a few questions in the chat. First question is, do you have a list of leading questions you use when finding users' biases and stereotypes? And since we are not the domain experts, sometimes it's hard to ask when you don't know what you even need to know.
I don't have a questionnaire for the users to ask what some of the limitations would be. However, there are a lot of interesting literature, not part of the data science world. You will find it in the psychology articles of how we interpret information and how we make errors. There are some popular books on the decision quality, which is a science of making good decisions. And also some of it could be useful from the study of the brain, how the brain accepts information and interprets it. So I suggest researching these areas and stepping a little bit outside of AI and data science to grow your understanding of that. And that would really prepare you for what biases they might be having. And then the next step is observing them, actually looking at them making those decisions and sitting down with them to understand how they're making it in order to spot the particular times when you notice that they are exhibiting the biases. You don't necessarily need to let them know about them.
Great, thank you. Next question is, how is AI augmentation different from what we already do today everywhere? I mean, nobody uses AI blindly anyway, so it is given that humans work together with AI.
That's a great statement, and it really brings up how AI augmentation isn't talked a lot, but is one of the key applications of machine learnings. So again, a lot of applications out there are designed to provide a score, provide a recommendation, provide a prediction, which is a number that might be fed to other system to that then they present a product to the customer or output just output it visually, like a weather forecast, for example. So the difference here is that we are working together with a human on making the decision, and we are making the process of learning and absorbing information easier for them. And sometimes we're making their performance better. So it doesn't have to be something different. I would say that's how it's defined.
Okay, cool. Nigel has a question. Thoroughly agree that you need to design trust into ML project from the beginning. Since privacy also needs to be built in from the beginning, is the discussion around privacy considerations with business stakeholders an opportunity to begin building trust in ML?
Yes, thank you, Nigel, for your question. Absolutely. Privacy actually comes at the very beginning of the process when we are collecting the evidence and considering what data we should be putting in to the process. In addition to that, since I've mentioned biases, you want to make sure that the data that you're putting in isn't biased in any way. So if you're displaying a particular segment of the users, for example, you could have a segment of users called New Canadians. Does it in any way bias the decision maker? So you need to be careful with a lot of data points, not just things like SIN number and passport number. There are a lot of ways to sway the users in different ways. So you have to consider privacy. You have to consider biases right at the beginning when you're collecting the data.
So based on the use case, we'll have a particular group to get feedback from, right? And have the humans in the loop. But then is that biasing, or we're just trying to get a particular group's consensus on something?
So I think what you are asking is how do we avoid ourselves biasing the people, right? So yes, so avoiding that is made by looking at the data that you're presenting to the users. So what I was covering is that process of simulating how they do it today. So what data are they looking at today? So it's not just getting them in a loop and having them review the model output. That's not the goal. The goal is to make them better and eliminate some of the biases that they might have. So I can give an example from the radiologists that I talked about before. So prior to them introducing this technology, the rate of misdiagnosis in young females was very high. And when they introduced the AI augmentation, it was reduced significantly because AI had no way of knowing the age of the patient. But the radiologist would meet them during the appointment. And at that time, there was a common bias where they believed that you shouldn't be having cancer in your early 20s. And so didn't get necessarily the early diagnosis for the younger patients wasn't as common as it should have been. So this is where AI helped to eliminate that bias by simply not introducing the age of the patient into the data.
Okay, thank you.
Do we have any other questions? Looks like I've answered most of them. Thank you so much, everyone, for your questions today.
Yeah, thank you, Olga from TMLS.